It's me, famous astrobiologist, Al Ian. And today I'm going to talk to you about astrobiology. Now you're probably wondering, what is astrobiology? Astrobiology is the study of all known life in the universe. At the moment, that's just Earth, but with how many planets there are out there, at least one is bound to have something, right? In order for life to form, there are three main criteria that must be met. Those three criteria being, one, must have liquid water, two, must have a stable environment, and three, there has to be a consistent source of energy. As well as a planet has to be in the Goldilocks Zone of its parent star. And the Goldilocks Zone is basically the part of the star's orbit in which the temperature is just right enough for liquid water to form. In fact, Earth, Venus, and Mars are actually all in the Sun's Goldilocks Zone. It just so happens that Venus has a really thick atmosphere which superheats it, and Mars has no atmosphere which basically freezes it, making liquid water impossible to form. On Earth, it is believed that meteorites came and seeded water onto Earth. But these meteorites happen to have ice inside of them, which the ice then melted and evaporated into the atmosphere, which then rained back down and turned into Earth's oceans. Now in these oceans, life began to form. Now as to how it formed, that's unknown. If you're a Christian, you believe it was probably God. If you're an atheist, I don't know, Darwin or something. But basically, the little microbial life forms appeared somehow, and they began feeding off of thermal vents deep down in the Earth's ocean. And also these oceans were pretty stable, so I mean, there you go. There's all three criteria met for Earth. Remember how I mentioned Venus and Mars were in the habitable zone of the Sun earlier? Well, it's believed that they might actually have had life on them at some point. Mars, there's direct evidence of what appears to be emptied lake beds or even river beds. And in Venus, some scientists believe that microbial life might live in the atmosphere, in the clouds, above all the really bad temperature, really warm temperature, you know what I mean. So now is as good a time as any to talk about how environmental conditions will affect how organisms will evolve. So an organism will adapt to wherever it lives and whatever ecological niches are available. So for instance, an organism that lives in water will adapt a tail and fins, while one that lives somewhere really cold will adapt something to keep it warm, such as fur or hair. The same is true of exoplanets. By the way, an exoplanet is just any planet outside of our solar system. But you see, on exoplanets, we have sort of an idea of what these organisms that live there might look like. You see, an organism that lives in a similar environment to one on Earth, say a creature living in an ocean, would more than likely look similar to a fish. This is due to a process called convergent evolution. You see, convergent evolution is the process of basically two distantly related animals that have no connection to each other, that evolve similar traits in order to fit similar needs in their environment. Let's take dolphins, sharks, and ichthyosaurs, for example. All three of these are not related to each other at all. Dolphins being mammals, sharks being fish, and ichthyosaurs being reptiles. However, they all evolved similar body plans in order to fit their environment better. On exoplanets, the environmental conditions could be wildly different from those of Earth, though. So that means astrobiologists have to look at different ways life could look according to these different environmental pressures. For example, gravity. For instance, there are exoplanets known as super-Earths, which are planets that are about 2 to 3 times the size of Earth that contain all the right environmental conditions for life to form. However, due to these planets' intense size, like massive size, that would mean the gravity would be super intense, meaning that animals couldn't get very big. Or they would have to develop really dense skeletal structures in order to keep themselves up due to all this gravity. As opposed to the opposite, which is planets that are really small. On those planets, animals can get massive without having to really worry about their skeletons. Astrobiologists even have to think about the very atoms that these animals or organisms are made of. For instance, here on Earth, everything is based on carbon. However, that is not to say that something on another planet would also be based on carbon. For all we know, something else could be based on silicon or even sulfur. More than likely, an alien organism won't even look like us. That means the blue cat people in Avatar, highly inaccurate, impossible to exist. Sorry. However, the field of speculative evolution has some pretty good examples of what extraterrestrial life might end up looking like. Speculative evolution is exactly what it sounds like. Speculative evolution is the study of, speculative evolution of organisms. So basically, a theorized evolutionary path that an organism could go down. Some good examples of speculative evolution projects are All Tomorrows, the Serena Project, and the Buran Project. All Tomorrows is basically the future evolution of humanity. It goes millions of years into the future to where humans are a spacefaring race. Now, humans have stayed relatively consistent looking over the years. That is, until an alien race called the Q show up and basically take humans and then just mold them into different body plans and put them on different exoplanets. For instance, some are put on really low gravity planets, and so they grow really tall and skinny, and they get wiped out by a race of giant chickens that got put there somehow. Another example would be some got smushed by really high gravity. They're just like a pancake race, I guess. And the really unlucky ones got turned into sentient bricks. They still have all their thoughts and consciousness. They are just bricks. They even have a little eye so that they can see. They remember everything that happened to them. They remember being human. The Serena Project takes place far off into the future, where a future civilization somehow took a bunch of animals from Earth and put them on some random moon. On this moon, they put a lot of animals, the most important one being canaries. You see, these canaries ended up taking a bunch of ecological niches and forming their own unique body plans. Some, for instance, grew giant tentacle faces. Others became a lot like dinosaurs. However, some ended up becoming intelligent and forming their own civilizations. The Buran Project tells the story of this fictional alien civilization that ends up developing over time to the point where basically humanity is. They even develop space travel. Speaking of these civilizations, let's talk intelligent life. Now, it's possible that there is intelligent life somewhere out there in the universe. In fact, NASA has been sending out radio signals for years to try and contact any. So far, we've not gotten any response unless you believe the WOW signal is intelligent life, which it might possibly be. In fact, I'll play that now. On the Voyager spacecraft, we even sent a golden record that contained a bunch of information about humanity. This information included diagrams of the human body, photographs of nature and Earth, sounds of nature and Earth, and songs. It also included a letter from former President Jimmy Carter. However, some people believe that we really don't need to be sending all these signals out into space. In fact, some of them believe aliens live among us. You see, the beginning of all of this mass alien hysteria started in July 8th, 1947, in Roswell, New Mexico, when a weather balloon crashed into the desert. It was quickly picked up by the military and shipped off somewhere. I don't know where. It got shipped off somewhere, though. But come on, we all know it wasn't a weather balloon. We all know it was a UFO. There was aliens in there. There were little green men. This would later go on to be known as the Roswell incident, only the second most notable thing about New Mexico. You know what the first is. More recently, the Pentagon released footage of what they are calling Tic Tacs. These supposed Tic Tacs are believed to be alien spacecraft. Also, reptile people run the government. Now, I will say, if these alien civilizations do exist, the likelihood of them coming to Earth is very low. You see, the Fermi paradox explains this. As proposed by Enrico Fermi, the Fermi paradox states that if there are so many aliens out there, where are they? Basically, what this is trying to imply is that aliens either aren't interested in Earth, or they don't exist. Challenging this, however, is the Drake equation. The Drake equation is an equation that precisely measures how many intelligent civilizations are out there. It was proposed by Frank Drake in order to help a committee of scientists try to figure out how much intelligent life there was in the universe. However, scientists need a way in order to measure exactly how advanced a civilization is in order to classify it as intelligent. This is where the Kardashev scale comes in. The Kardashev scale has three main points into which a civilization can be advanced to. The first one is when a civilization is able to take control of all the energy of its host planet. The second point is when a civilization can take control of all the energy from its host star. Level 2s have to be able to build a hypothetical structure known as a Dyson sphere. A Dyson sphere is a giant superstructure that encompasses the entirety of a star, so that it can absorb all its energy. The third point would be when a civilization can take control of its entire host solar system. Now, Earth on this scale would only be considered a 0.7. Now, all this astrobiology stuff is pretty good fun. It doesn't seem likely, at least for a while, that we'll be able to visit any planet to really study the ecosystem. For right now, all we can do is just theorize about what extraterrestrial life might look like. But hey, I'm Al Ian. Thank you for watching.
You're